Hello guys, Aasalamualaikum guys. In this video we are beginning the session on chemistry. So we are beginning with chemistry by learning what is catalyst in organic synthesis and addition reactions. So to learn that kind of concepts, stay tuned with my channel, Start Education Learn with Passion. Make sure not to be forgotten to subscribe this channel. And let's move on to the topic of what is catalyst. So catalysis is a process in which the rate of chemical reaction is either increased or decreased by means of chemical substance known as catalyst. Here, the catalyst refers to a process in which the rate of the chemical reaction either may be increased or decreased. A reaction which gives you the real results. That's what the catalyst is. So it may be either increased or decreased by means of chemical substance, and that substance is known as catalyst. So let's see the types of catalysts. There are two types of catalysts, that is heterogeneous catalyst and also the homogeneous catalyst. So heterogeneous catalyst is refers to the catalyst in which the chemical reaction is differ from others, and homogeneous reaction is the reaction in which the catalyst same types from each others. So let's move on to the next topic. What is next is so next is catalyst catalytic catalytic hydrogenation. Hydrogenation is a chemical reaction that results from the addition of hydrogen. Here hydrogenation is a process, is a chemical reaction that results by adding of the hydrogen. The process is usually employed to reduce or saturate organic compounds. For example, if we are having a CH3COOH compound and we want to hydrogenation that compound, so we usually add the hydrogenation. This process is known as hydrogenation. The process is usually employed to reduce or saturate or to reduce the compounds of reduce the reaction of the organic compound. The process typically constitutes the addition of pairs of hydrogen atoms to a molecule. The process typically constitutes the addition of pairs. Here's the addition of pairs of hydrogen atoms to a molecule. The addition of pairs of the hydrogen to a molecule. Catalysts are required for the reaction to be usable. Non-catalytic hydrogenation takes place only at very high temperatures. Hydrogen adds to double and triple bonds in hydrocarbons. Here, hydrocarbons is given in the screen itself. The bonds formed by the hydrogen is triple or double bonds, and that bond is known as hydrocarbon bonds. Here you may find that red H represents the addition of the hydrogen, and that is either double or in treble form. So the application in food industry. Vanaspati preparation. It is unsaturated fatty acid, that is oils, are converted into a saturated derivatives, that is by adding of the hydrogen. This is how the hydrogenation process works in chemistry field. So let's move on, and we have the Ziegler and Natta polymerization. Here, Carl Ziegler and Giulio Natta were awarded the Nobel Prize in Chemistry in 1963 for their discovery of the titanium-based catalyst. Here, titanium-based catalyst based on the titanium compounds and argon metals, aluminum compounds such as undefined methylaluminoxane or well-defined triethyl aluminum. Here the formula represents triethyl aluminum. Their natural catalyst can be used to prepare stereoregular polymers like isostatic, symbiotic, and actic. Here represents the Ziegler and Natta polymerization. So Diels-Adler reaction. Here the Diels-Adler reaction, namely 4 plus 2, is a cycloaddition of the gypsine and genopile, as discovered in 1926, is one of the most powerful methods for this geo and stereospecific preparation of carbocyclic and heterocyclic ring systems. Lewis acids increase the rate of the reaction and its regio, endo, and time space selective by coordination with the dynopile within with a conjugated carbonyl or nitroyl group. Here, interaction between the centers of the frontier orbital having the largest orbital coefficients. The interaction between the centers of the frontier orbital having the largest orbital coefficients. 4. The xenophile with electron withdrawing or electron releasing substituents orbital coefficients are high at beta carbon because the frontier orbital having the largest coefficient. We already know that the definition by the definition itself. So for the regiochemical relationships can be best understood by considering the atomic constituents coefficients of the foreign orbitals. The regiochemical relationships can be best understood by considering the atomic coefficients of the foreign orbital. That is, the forefront orbital represents the highest orbital coefficients. The regiochemistry can be predicted on the basis of the generalization that the strongest length with electron have withdrawing on electron releasing substituent at carbon C-1, that is carbon, and C, that is 1. The orbital coefficients are higher at C4 because of the entire orbital. So C4 is of gyne and beta carbon of the dinophile interact more strongly, leading